Illustrative Math, Algebra 2, Unit 6, Lesson 19 is called Beyond Circles. All right, our goal today is I can create a model of data that is approximately periodic, use the model to make predictions. All right, so here's some data that we will study in today's lesson. What do you notice? What do you wonder? So take a minute, pause the video, and see what you can come up with. All right, so here's some notices. First thing, the amount varies from 0 to 1. So notice the lowest I go is 0 right here. Highest I go is 1 at right here at 2, right here at 31. The numbers increase to 1, then decrease from 1 down to 0, then go back up to 1 again. Okay, so they go up to 1, and then they decrease down to 0, and then they increase back up to 1 if you follow it. Another thing, the numbers go down pretty regularly by about 0.1 between day 5 and 12. So if you look here, it's going down by about 0.1. These two are 0.1. This one was like 0.9, and then it got to be like 0.11, but pretty close. And then obviously they change. Like here, this is by 0.02, 0.01. So there you go. All right, some wonder. What do the numbers represent? Obviously, we know that this is day. This is amount of what? Why are the numbers when it decreases different than when it increases? Why are the numbers? I should say why are the numbers different when it decreases versus when it increases. Okay, so why are they different? Why are they increasing? Like here I go down 0.02, here I go up 0.01. Like you would think that it would be the same. Next thing, why don't the numbers increase or decrease at a constant rate? Obviously, like I said here, this is 0.02, and then all of a sudden it's 0.05, and then 0.07, different rates in between the values. Does this data continue past 31? All right, could you go to 32, 33, 34, or does it go below 1? Does it go 0, -1, things like that? You might notice because it goes from 1 to 31, you might think, does it represent 1 month? Okay, because usually there's 31 days in a month, sometimes 30 or 28. And is there a function to represent this data? Okay, so those are all different things. If you had some other things, go ahead and share them in the comments there. All right. The data from the warm-up is the amount of the moon that is visible from a particular location on Earth at midnight for each day in January 2018. A value of 1 represents a full moon, which all the illuminated portion of the moon's face is visible. A value of 0.25 means 1/4 of the illuminated portion of the moon's face is visible. Okay. Obviously, 0 would mean that there's no moon visible. That's what we would call a new moon. All right, what is an appropriate midline for the modeling of the data? So I would say since you go from 0 to 1, the midline is going to be right in the middle. So I would say that would be y equals 0.5 or 1/2. What's an appropriate period for the modeling of the moon data? So when I go back and look at it, I go from 1. It takes me, I don't hit 1 again until day 31. So 31 minus 2 is 29 days. So I'm going to say 29 days. Choose a sine or cosine function to model the data. What is the horizontal translation? I'm going to use a cosine function because right here I'm at 1. Cosine's at the high point at 1 here. So it looks like I'm going to need to translate that. So we're going to have to translate that left 1 to get it right here at the starting point. So Now, you might be wondering why I translated left 1 instead of left 2 to get it to 0. You could just say left days after January 1st because you don't have a 0 day of a month. So translate left 1 and, you know, we would say for days after January 1st, okay? So think of it like that. So at day 1, January 1st, that'd be 0 days after January 1st because you don't have a 0 day in a month, if that makes sense there, okay? So propose a function. So I'm going to say f of x equals amplitude is 0.5 because your midline is 1/2 and you go up to 1. Cosine of, well, I got to find b. I know my phase shift is left 1, so I'm going to put +1, but you find your period length. So your period length is equal to 2 pi over b. We know the period is 29, so I'm going to go ahead and erase the p and just plug in 29. If I cross multiply here, I get 29b equals 2 pi, and then divide by 29 to get b. So my b is 2 pi, let me erase that so I got a little more room, 2 pi over 29. So I'm going to write it here as 2 pi over 29x plus 1 plus 0.5 because I had to shift it up. All right, plot the data using graphic technology and check the choice of your parameters, midline, amplitude, period, horizontal translation. All right, let's do that. I already graphed it here. All right, there it is. Okay, this is my function. So notice on day 1 day after, so that'd be January 2nd, we're up here at the full moon. So this is, I'm gonna maybe label this days after January 1st, and then this is moon visible, amount of moon visible on the y-axis. All right. Let's see here. Number 6. Use your model to predict when the next 2 full moons will be in 2018. Are your predictions accurate? So I had it on the 31st, so I'd have to count 29 days from then. So March 1st, because there's 28 days in February, so that would be March 1st, and then another 29 days would be March 30th. Are your predictions accurate? Maybe check a calendar from 2018. Look at your full moons. I'm not going to do that right now for the sake of time, but if you want to, go for it. How much of the moon do you expect to be visible on your birthday? Explain your reasoning. Okay, so for your birthday here, I'm going to just say April 10th. Make it easier. My birthday is actually later in the year, but it'll be a little bit easier if I use April 10th. That's actually today's date as I'm recording this video. So so I got to go backwards 29 days. So if I subtract 29 days from then, I'm going to find the same day that corresponds to my birthday. Or I guess if I go back until I get to January, then I could figure it out. So April 10th. If I just subtract 29 days from then, I'll take me back to March 12th, 31 days in March. And then if I subtract another 29 days, I'll get to February 11th. There's 28 days in February. And then subtract another 29 days, and there's 31 days in January. That gets me to January 13th. So I go back to my table here and I look for January 13th. So January 13th would be 12 days after January first. So it'd be right there, 0.19. So, okay. All right, which parts of the moon modeling were most challenging? Whoops. I would say definitely that last part, estimating moon coverages for future dates, especially when it's far away, because the moon cycles appear to be 29 days, but each month doesn't have 29 exactly. So it's kind of hard. You got to just count back 29 days, which is kind of annoying. So like if your birthday was, December 10th, you'd have to count backwards 29 days and, figure it out, which is a little annoying. Was the prediction of how much of the moon will be visible on your birthday accurate? I think so, but I'm not gonna check that. I'll just cross that off. What could you do to improve the accuracy of the model? Obviously, we only have 1 month worth of data, so look at more data than 1 month. That'll give you a better estimate. We'll see if this repeats always the same amount. All right, goal. I can create a model of data that is approximately periodic and use the model to make predictions. Good. Moon coverage is definitely something that's periodic. Another thing that's not a circle, that's also periodic, is the tide. Again, I guess the tide is related to the moon's gravity. So if you measure the water level for the tide, that would be another thing that's periodic as well. All right, so our cool down. Titan is the largest moon of Saturn. They give us this function. It models the amount of Titan that is visible d days after a full moon. How many days does it take for Titan to complete its orbit of Saturn? Explain how you know. So we need to find the period, because a period is a full cycle. So my period is equal to 2 pi over b. B is here, d is my variable, so my b is this 2 pi over 16. So if I divide that, 2 pi divided by, so I'm going to multiply by the reciprocal, works out really nicely because that just cancels, so I get 16. So I'm going to say 16 days equals 1 period. So that's how I know. Okay, sketch a full graph of the function. So let's see here. If I got to go, my midline is 0.5. So maybe I could draw that midline here to help me. So 0.5 would be right there. Let's see here. If this is 16, that'd be 8, 12, 4. So we start at a full moon right here. 4 days, we're at half. 8 days, we're down to 0. 12 back up to half. 16 back to a full moon. And it'll look something like that. All right. All right, thanks for watching this video. Hope you liked it, and we'll see you next time.